Hello, everyone. How are you? How's it going? So, did you guys see what happened? Did you guys see what Miss Saba did in the video? She got a recorded part in the video. Did you guys see that? Rabia is texting. Yeah, that was oh my God. I think that was really funny. Thank you, Miss Saba, for the gotcha. All right, so we have 16 students here attending. That's wonderful. Abdullah, there's Ahmed, Ali, Aratrika is here. Oh, Aratrika, I still have, your thank you cards are here. I love them a lot. They are amazing. Thank you so much. And all those gifts were so good. Thank you so much for 2 years ago. She did amazing. She got a 9. We also have Aya, Dua, Mehdi, Malak, another Malak, Maryam, Maisam, Omar, Sabian, Samia, Tamara, and Zoya. Welcome, everyone. Thank you so much. Most of you were my students last year, so that's amazing. I don't know where Alma is. Rabia, can you check on Alma? Yusuf and Reem, they should be here. All right, so let's get started. I'm gonna thank you, Rabia. I'm gonna get started. If you guys have questions, you can put your questions in the Q&A. You can also Miss, by the way, Abdurrahman Higazi from 23. Oh, Abdurrahman Higazi. Oh my God. Of course, I remember him, 2023. It was such an amazing year. We had some really good results. Also, 2024, we had really, really good results. Thank you, Aya. So yes, this group, because it's the AS group, I know most of you, or you could be the siblings, or you could be some of my older students. So that's really amazing. And so today I'm going to teach you the first session of okay, this iPad was oh, here. Yeah. Okay, that's better. This is the first session of the AS level, the advanced level. If you are Cambridge, this session will work great. If you're Edexcel, this session will also work great because it's the identical content. If you're AQA, it will also work great. All right. So for all 3 boards, the content is the same. So today I'm going to talk about atomic structure. Before I start, just a quick announcement. There is a Q&A group that you can post, a Q&A box where you can post your questions if you have any. And of course, I'm looking at the chat and I'm reading your chat. Okay, so do not worry, you can chat as much as you want. And I really actually want your participation. So please put that on the chat. Hello, Rawa. And thirdly, if you want to open the mic, if you want to talk about something or ask something by talking instead of chatting, just raise your hand and I will unmute you. All right. Okay. Before I get started with my slides, I want to remind you that chemistry is absolute happiness. Who agrees with me? Just say me on the chat. Absolute happiness and excitement and enthusiasm. Yes, thank you. Malak, Dua, Rawa, Maisam. Maisam says, of course, all uppercase. Habiba, thank you so much. Aratrika, yes, that's lovely. Classes are fun, so actually enjoy, right? Those 2 hours, just enjoy them. Today's session is going to be about atomic structure. We're going to talk about isotopes, and we're going to talk about spectrometry. And actually, these 3 topics are related. All of them are related. Some content, some stuff you've actually heard about before. You actually studied about them before. And some stuff are going to be new. So let's get started with the first one. Oh, and by the way, we're gonna do some questions at the end. Okay, so number 4. No, I don't want this color. I want... Why isn't it not moving? Okay. Let's do this. Yep, this one. Okay, so number 4. Why is it not? I want pink. Can you give me pink? Give me pink, please. Okay, here. Nice. Okay, so number 4, we're gonna do questions. All right, is that fun? Questions from past papers, actually. So all right, my first topic here is atomic structure, something you already know, so I want your participation, okay? type, oh, thank you, Amr. Type your answer here. The atom is like the smallest particle. If I have a piece of paper and I cut a little bit of a piece of paper and I ask you, can you guess how many atoms are here? Can you guys guess how many atoms are in this piece of paper? Is it 100, 200, 300? Thank you, Maisam. Yep, it's not hundreds, way more. And oh, Karma is here. And it's not even thousands and it's not even millions. Okay, no one can guess. It's like billions and billions on billions and billions and billions of particles. Okay, it's trillions, exactly. Yes, it's a lot of particles. And so all these particles are called atoms, and each atom kind of looks this way. Now there are several surprises in this course, in this advanced course, because last year I was trying to simplify everything for you. So I was like saying, oh, the nucleus is like the sun and it's in the center, and around the sun there's these electrons that go and revolve in an orbital or in a shell in a circular way, like the planet around the sun. Now this year I'm gonna surprise you and tell you it's not really a circular path. That was actually a lie. It is not circular at all. It's making like a cloud around the nucleus. So these electrons are making a cloud around the nucleus. So that was kind of a small lie last year, but we still have shells. We call them energy shells, and electrons are at a certain distance from the nucleus. But we know that we have a nucleus, so something in the center, and then we have something around the center, which are electrons around the nucleus. They're just not revolving in circular path like I told you last year. Okay, so there's the nucleus, just like biology. In biology, what do you learn about the cell? You learn that there's a nucleus, which is heavy, right, and has DNA and stuff. And then there's stuff around the nucleus, which are basically water and dissolved stuff and mitochondria, right, whatever. All right, so same thing in chemistry. The atom has a nucleus in the center, and then outside the nucleus in something called energy shells. Omar, that's funny. In which those electrons exist. Now, inside the atom, there are subparticles. So there's the electrons, there's the protons, and there's the neutrons. All right. Now, what is the difference between these three? What are the differences between these three? There are mainly three features that are very different between these three, the protons, electrons, and neutrons. Firstly, the charge. Can you guys tell me what's the charge of protons? What's the charge of neutrons? What's the charge of electrons? All in one message. Boom, boom, boom. Thank you, Karma. Thank you, Habiba. Thank you, Maisam. Thank you very much. Excellent. Dua, thank you. Thank you, Karma. Yes, again. Thank you. Melek, excellent. There are 20. I want everyone to answer. I want 24 answers, please. Okay, Rawat, thank you. Ahmed Osama, wonderful. Aratrika, wonderful. Zoya, Abdullah Khalil, Mahi. You can put on the chat because this is the Q&A. Okay, wonderful. Okay, excellent. You guys still remember something from last year. That's good. Okay, so protons are positively charged. Thank you, Sabian. And Samia. And Dua, thank you. Protons are positively charged. Neutrons are neutral. They do not have any charge. Electrons are negatively charged. Now, what is a charge? A charge makes something attracted to its opposite. So a positively charged thing, anything that's positively charged, is going to be attracted to something that's negatively charged. Okay, now we as scientists, we just had to say this is positive and this is negative when we found that they are attracting to each other. And if they have the same charge, they, oh, I hate you. They repel from each other, right? Thank you, Maisam. Okay, now next thing is the mass. And so the mass of a proton, the mass of neutrons, the mass of electrons. Problem is we cannot really find the mass of these things. I just showed you a piece of paper. Here's my piece of paper again. I still have it. And this has billions and billions and billions of atoms. Now, if you put this piece of paper that has billions of atoms on a balance, it's not even going to give you 0.1 grams. all right? And these are billions of atoms. So we cannot really measure the mass of a proton or neutron or electron, right? And so scientists just had to say, okay, let's compare them with each other. Let's find. Now, they don't really have a mass. It's very, 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 very small. And so they just called it, thank you, Omar, exactly, and Maysam and Rawa and Dua. They just called it atomic mass unit. They just gave it 1 unit. And they found that protons and neutrons are kind of equal in mass. So they said protons are 1 atomic mass unit, 1 unit, and neutrons are 1 unit, and electrons are also 1 unit. Okay. Now, because sorry, I totally zoned out. And the reason I zoned out is that you guys know how picky I am with fonts and with my slides. Those of you who know me from last year, you guys know how picky I am. Yeah, okay, my son knows. And so my iPad was reset completely yesterday. And so I don't really have all my fonts and sizes and stuff like correctly here. So anyway, the scientists found that protons and neutrons are kind of equal in mass. Oh, that is here. Oh my God. Okay. So protons and neutrons are kind of equal in size. And so they said they're actually not exactly equal, but we're going to just let go. It's almost equal. Okay. So 1 unit each. Electrons were found to be very, very, very light. You need almost 2,000 electrons to be the same mass as 1 proton. So light, like last year we said it's negligible. Negligible means almost 0. Okay, but you do have to know this number. It's 1 divided by 1840. That's how light electrons are. Okay, and the way they knew that it's 1,840 times lighter than protons is by doing experiments. I'm going to show you the summary of these experiments today, something new, all right? Okay, third thing, what is the purpose? I did not talk about this last year. What is the purpose of protons? Does anyone know? The purpose of neutrons. Purpose, like why do we have did I say neutrons? I'm sorry, protons. Let's start with protons. Why do we have protons in the center of an atom? Purpose of protons to keep. Excellent, Rawa. Maysam, excellent. Omar, you're there. You're almost there. Yes. Anyone else? Atomic number. And what does the proton do in the atom? To have a mass cancel with the charge of the electrons. Thank you, Zoya. To keep the nucleus neutral. Thank you, Karma. All right. So let's say I have an atom here. Okay. And these are my protons, positively charged, right? What are these protons doing? Keep the atom stable. How? You're there, Habiba. Yeah. Okay, so here's what the protons are doing. They are attracting the electrons. If protons aren't there, what will the electrons do? Out. They will fly off, right? Nothing is going to keep them in the nucleus, in the atom, right? So the proton is like the boss. It's like mom at home, right? Mom is doing what? Keeping all the rules, keeping everybody right? So here's what the protons are doing in the nucleus. It's attracting all the electrons to keep them in the atom, okay? So it's attracting all the electrons. It's keeping them under control. It's the boss, all right? Okay. So protons they attract the electrons. What about electrons? Can anyone tell me about electrons? What is the purpose of electrons? Yes, they are in the atom. They are canceling the positively charged protons, but they're doing something amazing. Those electrons are doing something excellent, Omar. Excellent, Omar. First answer. Zoya, you're almost there. Yes, that's part of it. Yes, so electrons are around the nucleus. What are they doing? What's the purpose of them? How are they important? So important. How are they so important? Attracted to protons, yes, but Omar, yes, that's right. Canceling the charge. That's right. Okay. So I actually have one. I mean, you all answered kinda. Yeah, I mean, you do have good answers and all, but there's only one accurate answer, like really accurate answer. Just one student. Out of 22, not bad. We're learning. That's okay. All right. Anyone else? No other ideas? Okay. So electrons, the purpose of electrons, they undergo reactions. What do I mean by undergo reactions? So if they are lost or if they are gained, when electrons are lost or gained, we call them chemical reactions. When electrons are lost or gained, we call them chemical reactions. And so that's the whole fun. That's the whole idea, is that atoms react. They undergo reaction. They go lose electrons, they go gain electrons, and they combine with other stuff. And they do stuff, right? So, oh, Alma, you're here. How come you are 16 minutes late? Never do this again. You join on time, Alma. Okay, last time. I'm letting this go. I forgive you. Heart, love you. Okay, all right. What about neutrons? Okay, so the protons are keeping everyone in one place. It's the boss. It's like mom at home. You guys know how moms are acting, okay? Electrons are fun because they get lost and they get gained, and that's chemical reactions. What about neutrons? They're neutral. They're not doing anything. They're not attracting anyone. They are not lost or gained. They do not go and make chemical reactions. So what do neutrons do? Electrons are kids. That's nice. Ah, Omar, excellent. Look at you, Omar. Did you take this course already? That's so good. No? Okay, you're thinking. I love it. You're thinking. All right, so imagine Omar already said you just finished O level. Yeah, that's good. You're waiting for the results. Yeah, okay. All right, imagine if the neutrons are not there. Okay? After tomorrow. Okay, so imagine if the neutrons are not in the atom. We only have 3 protons. By the way, this is lithium, by the way, okay? What do you think is gonna happen if the nucleus is all protons, just protons, positively charged protons, and that's it? There's no neutrons. What do you think is gonna happen? Maysam, what do you think? Alma, what do you think? Malak. Yusuf. Is Yusuf here? Is Reem here? Okay, Aratrika, what do you think? Correct, Dua. Too light. Not exactly the answer. Yeah, I'm okay, Omar. I'm just not reading everything out loud. Yes, Aratrika, that's correct. That's correct. Maysam, opposite. I mean, good thinking, opposite. So imagine if everything is positive, everything in the nucleus is positive. What happens when like charges are together? All of them are positive, okay? What are they? Yes, exactly, Rawa. They are going to repel. There's not going to be an atom. They're just, they're going to fly everywhere. Okay, and so what the neutrons are doing is they are kind of like the glue to all the protons, okay? It makes them not repel each other. Now, I'll tell you something. I have 2 sons and a daughter. My 2 sons are so like 2 positively charged particles in my house. And they are just like fighting all day. But then I have a daughter. I have Julia. Okay, and my daughter is like the glue. She's keeping everyone together. Okay, bless her heart. And so neutrons is keeping everybody together, not fighting or repelling with each other. Okay, so neutrons are cool because they stabilize the atom. All right, maintaining stability, maintaining cool a cool house, a cool atom. All right, okay. Now, as we know, there's this amazing, creative, wonderful, genius scientist. His name was Mendeleev. At the time Mendeleev was there, like 200 years ago, there were many elements discovered. Okay, and they just had them randomly in circles, and they did not know how to arrange them. And he's like, okay, we've got to arrange these elements in a table. They called it the periodic table. There's a reason why they call it periodic table, because they go in periods. Okay, and that's right, Doc. And so the periodic table, there's many periodic table on the internet. Sometimes the small number is up, sometimes the small number is down, and sometimes it's colored, and there's various periodic table. I really want you to stick to your own board exam periodic table. So if you're Cambridge, stick to your Cambridge periodic table. Okay, it's not very different from what's on the internet, but I want you to get used to it. All right, so in the periodic table, you're going to find 4 information per element. Each element will have 4 information. So for example, this is lithium, and this is one of the information you will be given. You will be given the name of the element. And then what's Li? Can you tell me what's Li? Yeah, it's the symbol. It's kind of a nickname. Do you guys have nicknames at home? Does anyone have a nickname at home? Yeah, yeah, okay, exactly. So that's the nickname. Li is the nickname. All right. And what about the smaller number? What is the smaller number? Can anyone tell me? Can you guys tell me what is the smaller number? Excellent. عدي ماهي ملك Mahdi, sorry. Mahdi. One of my team members, her name is Mahi, so I got confused. Mahdi, that's correct. Atomic number, proton number. Thank you, Zoya, Karma, Habiba, Dua. Wonderful job, guys. This is the proton number, the number of the protons. Why is it so important to put the number of the protons on the periodic table? Why do you think it was so important specifically to put the proton number in the periodic table? Not the electron number, not the neutron number, proton number. Excellent, Maisam. Oh, Maisam, I'm so proud of you. Abdullah, that's right. Okay. Rawa, that's right. No, Omar. That's fortunately not. This topic is not in this year's topic. Okay, so Rawa, Karma, and Maisam answered. Osama, that's correct. Repeat the question. Why is it so important to have the proton number in the periodic table? What is the significance of the proton number? Why is it so important? What does it do? The proton, excellent, Zoya. Thank you. To know how many electrons, that's kind of correct also. All right, so proton number, actually, the proton number identifies your element. It tells you exactly what this element. Why is that so? Because the proton number is like the fingerprint of your element. If you have 3 protons, it means it's lithium. It cannot be anything else. If you have 11 protons, it means it is sodium. It's a fingerprint. If you have 13 protons, it means you have people with good memory or people who have the periodic table in front of you. 13 protons means what? It means I have what? Excellent, Rawa. Yeah, she corrected herself. Yes, thank you. Rawa was the first. Okay, 13 protons. It means what's the element? Thank you, Maisam. Karma, 13, not 12. Okay, we have some amazing answers here. That's correct. If you have 13 protons, it means we have aluminium. And it cannot be anything else. It's the fingerprint. It's the identity. All right, if you have this fingerprint, it means it's so and so. Like it identifies who this person is. All right, the 4th number is the bigger number. And this bigger number is the mass number. Okay, so what do I mean by mass number? How heavy the atom is. Now, what determines the heaviness of an atom? I just said here that in this previous slide that electrons are very, very, very light. They almost do not have a mass. So I'm not going to count the electrons. What am I going to count? Thank you, Uday and Alma and Maisam. Excellent. I am going to count only protons and neutrons. So for example, this is lithium. I have 3 protons. I have 4 neutrons. So 3 plus 4, that's 7. And so I'm going to have the number 7 right here. And this is going to be your mass number. And so your mass number is basically protons plus neutrons. All right, protons plus neutrons. Who likes Kahoot? Because I think I have this question in the Kahoot. I think, I'm not sure. All right. Yeah, I love Kahoot. Let's see who's gonna win today. We have a very small class, so there's only 20 students. So it's gonna be a really easy competition, right? Okay. Just a question. We didn't use the electron instead of proton because they are lost and gained. Yes, exactly, Omar. That's right. In the periodic table, we do not say electron number is 3 because this electron number actually gets lost and gets gained and stuff like that. Okay. Mass number also identify the number. The mass number does not identify your atom. It only tells you how heavy it is. Okay. And there's something that I will cover in another class. This number can sometimes be a decimal. It should be a whole number, right? It's protons plus neutrons. But sometimes it's going to be like 6.9. Like, where did that come from? Exactly, what we're going to talk about that. And we did study it last year. Now, since you have the big number, which is protons plus neutrons, okay, so this big number is protons plus neutrons, and you have a small number, which is protons only. So you have protons and neutrons in this big number. You have protons only in that smaller number. What can you calculate from this information? Aha, thank you, Maisam. Thank you, Rawa. Thank you, Alma. No. What? You have the protons and the neutrons. You have protons only. What can you calculate? Omar, thank you. Auday, thank you. Karma, thank you. You can get neutrons, guys, math. Yeah, you subtract, right? And so the number of neutrons is going to be the mass number minus the proton number. So how many neutrons do we have for lithium? How many neutrons do we have for lithium? Yeah, 7 minus 3, which is 4 neutrons. Okay, now I'm going to review the rules that we had last year. There are 2 rules in the periodic table. Now, the periodic table looks like this. You're going to have a slightly new periodic table this year. Okay, and this is basically the slightly. Did you guys notice what is new? It looks very similar to last year's periodic table. However, you're going to see some decimals. All right, it's more accurate. That's one difference. Thank you, Uday. Thank you, Rawa. And one more thing that's a little different, just very little different. Exactly, Rawa. Exactly. Okay, did you guys notice what else is different? Exactly, Maisam. Yes, Marwan, the decimals, and one more thing. Aha, Uday. Excellent. Why are they decimals? We're going to talk about that. Omar, yes, that's right. So the groups, we used to have this as 1, 2, 3, 4, 5, 6, 7, and 8, right? Now they're going to call it 1, 2, 3. The transition metals are going to take groups number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then group 3 this year, instead of group 3, we're going to call it group 13. Okay? Yeah, Marwan is like, what? I don't want that. Guys, it's a small difference. Yeah, my son is like, this feels like betrayal. Okay, and group 4 is now called group 14. Group 5 is called group 15. Group 6 is called group 16. Group 7 is called group 17, and group 8 is called group 18. Okay, so transition metals now have a group number. All right. Trust me, this is not significant. This is nothing. Okay. Back to that's not hard. Going from 5 to 15, I mean, it sounds very similar, right? I mean, that's not very hard, okay? So the 2 rules that we studied last year is that we have columns in the table. We also have rows in the table. The columns are called... excellent Dua, excellent Omar, excellent Maisam. Where's everyone else? Why are they only 3 students answering? The columns are called groups. Yes, groups, not periods. Who said periods? Focus. Did you zone out? Okay. The columns are called groups. And the groups correspond to what? The groups actually tell you something. Excellent, Alma. The groups will tell you the groups will tell you what. So if it's group 1, what does that tell you? It tells you something. Excellent, Rawaq. It tells you the number of outermost electrons. So group 1, everything in group 1 has 1 outermost electron. Everything in group 2 has 2 outermost electrons. We call it valency electrons. Aratrika, do you remember? Everything in group 3 or 13 has 3 outermost electrons. Everything in group 4 or 14 has 4 outermost electrons, and so on. Everything in group 8 has 8 outermost electrons. Easy? Okay. What about rows? What do we call them? What do we call rows? We call rows Alma, Karma, Dua, that's right. Rawa, Malak, Habiba, Marwan, that's right. Aday, Abdullah, Asil, Sibian. Sibian or Sabian? How do you pronounce your name? I want you to open your mic at one point and tell me how you pronounce your name. Mahdi, that's right. Ahmed Walid, that's right. Osama, that's right. Okay, yes, that's right. We call them periods, okay? And they correspond to what? They tell you something. Those periods, they tell you something. So if something is in period 3, it means we have... Excellent. It means we have 3 shells. Thank you very much. So it corresponds to the number of shells. Now, can you guys, without looking at the periodic table, do you remember how many groups do we have and how many periods we have? How many groups? Let's start with groups. How many groups do we have? We have 8 total groups plus 10 transition metal groups, okay? What about periods? How many periods did we discover so far? Who knows how many periods can exist or how many shells? Exactly, we have 7 periods or 7 shells. That is wonderful. All right, let's do a small exercise, okay? And I want you to be very fast because it's just one number, okay? Let's do phosphorus, okay? Let's do phosphorus, P, okay? How many outermost electrons are in phosphorus? How many outermost electrons are in phosphorus? Excellent. It's 5. Why did you say there are 5 outer electrons in phosphorus? Because it's in group 5 or 15. Okay. And how many shells are there in phosphorus? How many shells are there in phosphorus? People said 3. Excellent. 3. Why? Because it's in period 3. Now, here are the period. Some students will say 2. Why? Because they forgot that hydrogen and helium are actually number 1. So hydrogen and helium are period 1. Okay. Lithium to neon is period 2. Sodium to argon is period 3. And so phosphorus is period 3. All right. Does anyone remember electronic configuration? Does anyone remember electronic configuration? What is the electronic configuration of phosphorus? Phosphorus has 15 protons and therefore 15 electrons. Maysam, Rawa, Uday, Zoya, Karma, Malak. Yeah, Marwan, I'm going to talk about that. Thank you for noticing. Omar, Mahdi. Whoa, this group is so good. You guys remember Asil? Thank you very much. Exactly. We have 15 electrons, and those 15 electrons are distributed. They're not all randomly sitting in any random place. No. The first shell can only occupy 2 electrons. The second shell can only occupy 8 electrons, and therefore, the last 5 electrons will go to the third shell. And so the electronic configuration is 2, 8, 5. Easy? Dua? Was that a typo? Yeah, okay. All right, wonderful. That's amazing. Let's actually do one more. Barium. Let's do barium. Can you tell me how many outer electrons are in barium? Outer electrons. Excellent. 2. Why? Because it's in group 2. See? The periodic table helps you cheat. And it's available in the exam. Right? Okay. How many shells are in barium? How many shells are in barium? Look at you guys. Exactly. This is 1, 2, 3, 4, 5, 6 shells, right? So this is period 4, 5, and 6. So yes, barium has 6 shells, okay? And the electronic distribution is going to be a little bit more complicated, right? It's 2, 8, 18, blah, like you do not have to worry about this, okay? All right, that's amazing. However, Omar typed something here. With these rules, there are 2 problems. 2 problems. Based on these rules, there are 2 problems. Did anyone catch these 2 problems? So there are 2 things that do not follow these rules. We just said that the group number corresponds to the outermost electrons. We just said that the group number corresponds to the outermost shells. So if it's in group, if it has 1 outermost electron, it should be in group 1. If it has 8 outermost electrons, it should be in group 8. However, the excellent Aratrika, excellent Karma, excellent Rawa, there are 2 elements that have a certain number of outermost electrons, but they're not placed in that group number. What are they? Alma, thank you. Dua, thank you. Samia, thank you. Yes, that's right. That's right. So here are the 2 exceptions. The first one is hydrogen. Hydrogen has 1 outermost electron. Where should it be? It should be in group 1, right? Dua, I love you too. She's sending me love messages on Zoom in class. I love it. Oh my God. Yes. So hydrogen should be in group 1. And indeed, if you search up Google, some periodic tables will have hydrogen in this place. Okay. However, this is really wrong and stupid. I mean, at the beginning, yes, scientists actually put hydrogen here in group 1. But then they're like, ooh, no, that is stupid. No, I don't know. We don't want hydrogen in here. Why didn't they keep hydrogen in group 1 and they moved it to a really random place in the middle of the periodic table? Why? Exactly, Maisam. Exactly, Rawa. Alma, that's right. Omar, no, that's not the reason. Karma, that's correct. Excellent, Osama. Excellent, Samia. Mahdi, that's actually a good point. What's the question? Why is hydrogen not in group 1? Why did they have to move it away from group 1? Even though it has 1 outermost electron. And so it should be in group 1 because it has 1 outermost electron. Zoya, that's correct. Omar, that's correct. And the reason is everyone in group 1 behaves in a very similar way. They all have 1 outermost electrons. They are all metals. They all conduct electricity. They all react with water. They all have the same properties. Mendeleev was really happy about the matching properties thing. He was like, his mind was blown. He was like, whoa, everything that has 1 outermost electron behaves the same way. Everything that has 2 outermost electrons behaves the same way. Everything that has 4 outermost electrons behave the same way. They're acting similarly. They're like brothers and sisters. They're behaving the same way. Hydrogen was weird. It did not behave like the rest of the family. It is not a metal. It doesn't conduct electricity. It is a gas at room temperature. It doesn't react with water like others. It's very, very different. And so scientists were like, or especially Mendeleev, he's like, oh, it doesn't match. Let's not put it in group 1. Okay? Yeah, so we had to abandon hydrogen and put it in another place. And so that is the first exception. Hydrogen is not in group 1, and the reason is it doesn't behave like group 1 metals. All right, what is the second exception? The second weird thing. Something that has a certain outermost electrons, but we did not put it in that place. Excellent, guys, you are amazing. Helium. Helium has how many outermost electrons? Helium has how many outermost electrons? 2. Where did we put helium? Not in group 2. How come? I mean, helium has two outermost electrons. We should put it with beryllium, magnesium, calcium, strontium, barium, right? We did not do that. Why? Because helium did not act or behave like group 1 metals. How did helium behave? Very different. Helium is lazy, unreactive, it's noble, it's like, duh, I don't want to react, right? It's like a princess. That's exactly right. Now, and group 8, everybody in group 8 are very unreactive. Why? It happens that any atom with 8 outermost electron becomes really happy. Remember the first slide? Chemistry is happiness. That's exactly what's happening here in group 8. Everybody in group 8 is really happy, very unreactive, very stable. And so it doesn't react with other people. And so they found that helium acts like a stable person, acts like a stable atom, and it doesn't react with anyone. And that's why they put it in group 8. Now, how come something with only 2 outermost electrons is stable? How come? Exactly, Maisam. Because it's considered full outermost. Why? Because the first shell only occupies 2 electrons. Now, is everything clear so far? Because I'm going to go into awesome. Okay, Eratrika says everything's clear. Karba says it's clear. Dot says it's clear. This is really a repetition of last year. I'm just summarizing everything from last year. So anything that has 8 outermost electrons is stable, unreactive. And having only 2 electrons in the first shell is also considered to be stable and unreactive. And we consider it to be full shell or full outermost electrons. Okay. Back again to the fact that chemistry is happiness. Atoms behave like people. They want to be happy. And so if they don't have this magical full 8 outermost electrons, what do they do? If atoms do not have my magical, wonderful 8 outermost electrons, what do? They go find a way to become 8 outermost electrons. They go find a way to have an electronic configuration that is similar to the noble gases. They are jealous from the noble gases. They're really looking at the neon and argon and krypton, and they're like, ooh, I really want to be like you guys. All right? So that's what they do. Atoms are neutral. They have protons and electrons that are equal, and so if they are neutral, there's no charge in them. But they don't stay that way. They go and seek happiness. They find a way. And so they and last year, if you guys remember, last year I had a whole lesson, 2 hours, dedicated to this fact, formation of ions. So they either lose electrons, 1, 2, 3, 4 electrons, or they gain electrons, whichever is easier, right? They find a way, they lose electrons or they gain electrons to become happy, to have 8 outermost electrons. Now, if an atom loses electrons, who's bigger now? It's not neutral anymore now. Protons are not equal to electrons now. Who's bigger now? Now that it lost electrons, which charge is bigger? There's more positive than negative. So the overall charge is positive, exactly. And now it's not an atom anymore. We call it ions. Why? Because it's a charged particles. We call it ions. And these ions are going to be positively charged, either +1, +2, +3, depending on how much they lost. Now, positively charged ions have a name. Meow. Anyone remembers? What is the name of positive? Yeah, exactly. Cation, cations, or cations are the names of positively charged ions. Okay, what if the atom gains electrons? Now, which charge is higher, positive or negative? Yes, the negative overall, there's more negatives than positive. And so the overall charge of, it's not an atom anymore, it's an ion now. This ion is going to be negatively charged, -1, -2, and so on. And what do we call them? Negatively charged ions, what do we call them? Anions, thank you very much. We call them anions, not anions, anions. Okay, all right. Now, how did scientists know? How did scientists know that we have charged particles? Because guess what? About 200 years ago, not very far, by the way, if you think about it, 200 is not very long, okay? Just 200 years ago, scientists thought that atoms are just neutral spheres, and that's it. There's nothing in it, nothing special in it, just neutral spheres. And atoms are, I mean, atoms of plastics are different than atoms of metals, and that's really all they had. But then came a scientist called Thomson, okay? You don't have to know his name, but Thomson came in and he's like, wait a second, no, these are not just, I mean, yes, overall, the atom is neutral. However, this neutral thing has oppositely charged particles. It has positives and negatives, and that's why it's neutral. But there's inside the atom, there's oppositely charged particles. There's positive particles and there's negative particles. How did he know that? He made an experiment. He connected, he basically ran electricity through a metal, okay? And you guys know that when electricity is passed, this is going to be called cathode, negatively charged cathode, positively charged anode. Now, at the time, they did not know that electricity is basically passage of electrons and stuff. But he passed electricity, he passed high voltage, and then what happened? Now, they did not know why it happened. No, but it's funny. What happened is that this is a metal, right? What do we know about metals now, 200 years later? What do we know about metals? Metals are atoms that have free outermost, that outermost electron is actually free, delocalized electrons, you guys remember? So what happened is this metal, when exposed to high voltage, those free outermost electrons were lost, were freed up. They flew out of the metal and they moved in this straight line. Now, this beam of electrons, again, Thomson did not know these are electrons. Okay, he did not know what's the charge of, but he knew something is moving. Okay, these beam of electrons are totally transparent. However, when they hit the fluorescent screen, they kind of make a glow. They glue in this fluorescent screen. Okay, so they did this glow. And that's how Thomson knew that, hey, this metal is emitting something. Something is leaving this metal. There are particles, light particles leaving this metal. Now, how did he know that these particles are actually negatively charged and not positively charged or not neutral? How did he know? So he knew because he put this device between two plates, a positively charged plate and a negatively charged plate. So here's the device again. Here's the beam of electrons moving. Here's the fluorescent screen. And the beam of electrons is making the fluorescent screen glow. Okay, and here's a real picture of it. And what he did is he put a plate above and a plate below. This plate was positively charged. So let me draw the plate. So here's the plate right here, positively charged. Here's the plate right here, negatively charged. Okay, he put these two plates oppositely charged, like one is positive, one is negative. Now, how does he put a plate that's positively charged? Just connect it to electricity. That's it. Very easy. Okay. What do you think happened to the beam of electrons? What do you think happened to the beam of electrons? Instead of going in a straight line and hitting the fluorescent, excellent, Maysam. Excellent, Adai. Excellent. Who else? 3 people answered. Where are you guys? Excellent, Dua. Yes, that's right. So I'm going to repeat the question. The electrons are moving here in a straight line. And Thomson put a positively charged plate above and a negatively charged plate below. What do you think happens to that beam of electrons? It's not going to go in a straight line, right? It's going to move a little bit up. It's going to be deflected. It's going to turn, right? So this beam of electrons will actually move like this. It will turn and it will deflect. Why? Because it gets attracted to the positively charged plate. So that's how Thomson is like, ooh, this beam of thing, it's charged. It has a charge. It gets attracted. So hold on, guys. Atoms are not just neutral particles. They have stuff inside it. They have positives and negatives. All right. And then after this experiment from Thomson, they did hundreds and thousands of experiments. I'm not going to give you, you guys do not know anything. You do not have to know anything about these experiments. All you have to know is like the summary of these experiments. And so what scientists did is they were able to pass a beam of anything, protons, neutrons, electrons, atoms, ions, everything. They were able to pass a beam of particles between positives and negatives. And they would just experiment. Is it going to go straight line? Is it going to move up? Is it going to move down? Is it going to move up a lot? Is it going to move down a lot? And so on. And I want you guys to guess. If you pass a beam of neutrons between these oppositely charged plates, excellent, Maisam, what's going to happen? Excellent, Alma, excellent, Karma. Karma, I'm so proud of you. I mean, wow. Okay, good. Rawa, yes. Yes, Dua, yes, thank you. I almost fainted. Excellent, Osama. Excellent. Look at you guys. Neutrons are neutral. They do not have any charge. So they're not going to change direction. They are just going to go in a straight line like this. Okay? Why? Because they have no charge. Okay, let's talk about electrons. What's going to happen to electrons? Thank you, Sabine. What's going to happen to electrons? Electrons. Yeah, they are going to turn, right? Which side? Up or down? Sorry for the prank. Yeah, they're going to turn up, right? They're going to turn up and get deflected and get attracted to the positively charged place, right? Why? Because electrons are negative and this plate is positive. Now, do you think it's going to be deflected a lot or a little? A lot or a little? Is it going to deflect it here like this? Or do you think it's going to deflect it far like this? Is it going to be deflected far? Close or far? Actually, very close. Very, 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 very close. Why? We're talking about electrons, Aratika. Why do you think electrons are going to be deflected so quickly, so sharply, and so close? Exactly, Aratika. Exactly, Maisam. Exactly, Osama. Exactly, Oday. I think I found, yes, that's right. Electrons are so light. They have no mass. They are 1/1840 of a proton. They're very, 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 very light. Thank you, Habiba. Okay, and so they get attracted, they get deflected sharply. They turn sharply. Okay. All right. What about protons? Where do you think protons are gonna go? Straight line? They're gonna go up, or they're gonna go down? Up, down, straight. Down. Thank you, because they're positive. Okay, they're going to go down. Do you think they're going to go down sharply like this or far like this? Ah, look at you guys. Smart group. Far. Very, very, very far. Almost 2,000 times as far as electrons. Why? They're heavy. Right? And so that's why the deflection is going to be much less deflection. All right? And so here's the protons with very little deflection. Here's the electrons with a lot of deflection. And scientists were actually able to calculate the angle of deflection and everything. Okay? But we do not have to make this calculation. How's everything so far? Because we're done with the first topic, kinda. We're going in to talk about something else, not super different, but very related to the atomic structure. So, as you guys know, scientists discovered so far 118 elements. Okay, a lot of elements. Some of them are very famous, like oxygen, nitrogen, right? Hydrogen, very famous. Carbon, very famous. Your whole body is carbon. And some of them are less famous and so on. However, they found out that each element could have types, different types. So they found out that oxygen, whoa, there are 3 kinds of oxygens with 3 different masses. Okay? Yes, Osama, I will send it to the group. All right? Oh, Doha, you're so sweet. Argon, there are 2 kinds of argon. There are 2 kinds of neon. There are 3 kinds of carbon. Whoa! 3 kinds of hydrogen. There are 2 kinds of nitrogen, 2 kinds of chlorine. Whoa. So what do I mean by kinds? Anyone here into cars? Have you guys ever went to the car dealership with your parents ever before? That's I do not like going to, like, I make my husband do this stuff. Okay, so if you've ever been into the choice of choosing a car, all right, I don't like choosing cars. I just tell my husband, Joe, just go and pick whatever within our budget. Okay, if we can afford it, just go and buy. I don't care. But anyhow, you go to the dealership. And then they give you choices. Here's BMW, here's Volkswagen, here's Toyota, and you pick. And then say, for example, you picked BMW. All right, I'm done. I picked BMW. What do they say? They say, oh, there's types of BMW. There's this model, and there's this model, and there's this model, and they make you pick. And oh my God. So, for example, you already paid and bought the BMW. Now you have a choice. Now, I'm really not into types or models of car. Like, I think my car is L, and there's XL, and there's whatever, but I'm not into the types. So I'm going to talk about colors, okay? Say, for example, BMW, um, it is still a BMW car, but there are 2 colors. They're going to make 2 colors. Why? Because of many, marketing reasons, people's choices and stuff like that. But say, for example, BMW decided, I want to pick gray, okay? They decided to make 75% of their cars gray or black, all right? And they decided to make red. Where's the red? And they decided to make 25, still getting used to this here. Okay. And they decided to make 25% of the cars red. Okay. So that's the company's decision. How's this related to chemistry? Can anyone tell me? How's this related to chemistry? Yeah, that is right. Because, as I said, chemistry is happiness, because chlorine, all chlorines in the universe have 17 protons, right? That's the identity of chlorine. All of them have 17 protons. However, when God created chlorine, God created 3/4 of chlorine to be a little bit lighter, and 1/4 of the chlorine to be a little bit heavier. So most the chlorines, just like the gray or the black car of BMW, most chlorines have a mass of 35, which means the number of neutrons are 35 minus 17 is going to be 18. And 1/4 amount of the chlorine are 37, which means the neutron number is 20. Both are chlorine, but there's 2 kinds. Okay. Again, you went to a dealership, you went to Toyota this time, and they say, okay, you bought a Toyota, congratulations, let's get started. Go pick a color. Ugh. Okay, you now have to pick a color. Happens that Toyota makes 99% of their cars blue, and then they make 1% of their cars purple. Have you guys seen a purple car? Very rare. And rare occasions, they will make an orange car. Okay, when you see this on the street, you're like, whoa, orange car. Okay, and so how is this related to chemistry again? Aha, exactly. Rawa was able to guess which element has 3 isotopes with these percentages. only رواق. Which element has 3 isotopes with these percentages? Excellent job, guys. Hydrogen and carbon also. Thank you very much. So hydrogen, all hydrogens in the universe have atomic number 1. So 1, 1, and 1. However, some hydrogens have atomic number 1, which means the neutrons are 0. Some hydrogens have atomic number, mass number 2, which means neutrons are 1, and that's really just very little, only 1% of hydrogen. And rarely will you ever find an orange car. All right, rarely will you find a hydrogen with mass number 3, which means it has 2 neutrons. Okay, and carbon is also a similar way. I have a slide for the carbon. And so basically, to summarize this, guys, what is the identity of an element? What identifies an element? Whether it's an isotope or what, I don't care. What identifies an element? Excellent, Maysam, Dua. Excellent. Habiba, Samia. Are they? What identifies the element? What tells me this is chlorine? This is hydrogen. Thank you, Aratrika. That's correct. Alma, that's correct. Karma, correct. Mehdi, correct. Sabian, yes. It's the protons, guys. It's the protons. It is not the neutrons. The neutrons could be different. As you can see, we could have different car models, different colors of cars or different number of neutrons in the element. But what identifies the element is protons. All right. So atoms may have, it could be the same protons, but the neutrons are different. So if it's the same number of protons, it's the same identity, it's the same element, it is still chlorine, but the neutrons are different. So everything is the same. Number of protons are the same. Number of electrons are the same. What's the only difference? What could be different if you have different kinds of isotopes or different models or different colors? Hello, Ahmed Abu Bakr. Excellent, guys. So everything is different. Everything is the same. I mean, everything is the same. The number of protons is the same. And if the number of protons is the same, it means it's the same element, of course. And the number of electrons is the same if it's neutral atom. And isotopes also undergo reactions and they lose electrons and they gain electrons and all the fun stuff. But they have different number of neutrons. And if they have different number of neutrons, we call them excellent. We call them isotopes. Now, there are many examples of isotopes. Guys, almost all elements in the periodic table have isotopes. Almost all. I think only fluorine and aluminium do not have isotopes. But other than that, most of them have isotopes. Some have 2 isotopes. Some have 3 isotopes. Some have 4 isotopes. Iron has 5 isotopes. And scientists were considering, I mean, they did not implement this idea, thankfully. That would be a really stupid idea. They were thinking to call each isotope something completely different. So bromine and blah blahine, okay, for the 2 isotopes. Yeah, Maysam, exactly. Imagine if the 5 irons have different names. Iron and something and blah blah blue and blah blah blee and blah 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 and oh my god, that would be horrible. So good thing they did not do this with all the isotopes. However, one mistake slipped. One element slipped. They did this with one element. Exactly, Rawa. They did this with one element and they called each isotope something different. And now we have to learn that. And I'm going to give it to you in one slide. I'm going to show it to you. Okay, let me show you some examples. Exactly, Usama, that's right. No, not the carbon, something else. For example, neon. There are 2 kinds of neon. Both of them are atomic number 10. But one of them, it has a mass of 20. One of them has a mass of 22. And therefore, what are the number of neutrons? Not chlorine, no. Number of neutrons, 20 minus 10, so 10. Number of neutrons here, 12. Now, are they equal in the universe? No. God did not create them equally. The neon, the lighter neon is 90%. So most the neon in the universe is the lighter one. And 10% is the heavier neon. And I did draw a diagram here. This is a sample of neon. Okay, now I could not draw the millions and billions in a sample of neon. So I just drew, I think, 20 particles here. 90% of these particles are the lighter neon. And only 10% of this sample is the heavier neon. Guys, examiners can sometimes be nice. They sometimes may just ask you, what is the definition of isotopes? I mean, if that question comes in the exam, come on, guys. 2 marks as a gift. Can you guys give me the definition of isotopes? Definition of isotopes? Okay, take a 30 seconds to write the definition. At least, excellent, Maysam. Excellent, Maysam. I want 21 answers. Atoms of the same element, same number of protons, different. Excellent, Aratrika. Oday, yes. Dua, yes. Usama, yes. Rawa, yes. Alma, yes. Atoms, different atoms of the same element that have the same number of protons. Thank you, Zoya. But different number of neutrons. Thank you very much. Excellent. Okay, question. Instead of saying same number of protons, can I say something a little different? Instead of saying same number of protons, can I say, excellent, Rawa and Maysam? Exactly. I can say atomic number with same atomic number. So I can say with same atomic number. And instead of different number of neutrons, can I say something else? Can I say different? Excellent, Rawa and Maysam and Malak. Different mass number. Excellent job, guys. Thank you very much. Okay, another example of isotopes, chlorine. Both chlorines have an atomic number of, thank you, Aday, that's correct, 17. Both are chlorine 17. However, God created some chlorines to have a mass number of 35 and some to have a mass number of 37, which means this first one has number of neutrons 18. The second one is a little bit heavier, mass number of 20. And I'm going to show you exactly how they found out this difference in mass. Okay. In chlorine, 75% of the chlorine are the lighter, 25% of the chlorine is heavier. And you guys have to know this information. You are required to know it. But I'm not worried about that because you know this information from last year. There's nothing new here. Okay. Carbon, another example. Your whole body is made of carbon compounds. There are 3 isotopes in carbon. All of them are 6. All of them are atomic number 6. But some carbons have a mass number of 12. That's the common one. That's the 99% one. That's the blue car of Toyota. 99% of carbon are 12. But there's like this 1% that is carbon 13. And there's rare carbon 13. Okay, now to the fun isotope. The most fun isotope, in my opinion. Most fun and most, like, kind of disappointing. Are we memorizing? Does that need memorizing? I mean, remember the car example, Toyota, right? Okay. Hydrogen. Hydrogen also has 3 isotopes. All of them are hydrogen 1. But the most common, the 99% hydrogen, also has a mass number of 1, which means no neutrons. Neutrons equals 0. I'm going to write that down. Neutrons is 0. This one is a little heavier. This one is even heavier. This one, that's 99%. This is 1%. And this is rare. If you find it, you are lucky. All right. So this is a mass number of 2. This is a mass number of 3. Now, here's the thing with hydrogen. Scientists, guys, I'm sorry, but you have to learn this. Scientists gave each hydrogen a name and a symbol. Yeah, they named it. Fortunately, they did not do this with everything else in the periodic table. I think they learned their mistake, right? Yeah, so you do have to know the name. The first hydrogen is called protium. Why did they call it protium? Because it has a proton, one proton, okay? Protium. The second one, you guys know that two in French, deux is deux in French, right? Deuterium. Deuterium. Un, deux, trois in French, trois means three. Tri. Tritium. Tritium. Protium has a symbol that is still H. Deuterium, the second isotope, was the scientist French? I think, maybe, I don't know. D, and tritium is T. But anyhow, easy to memorize, right? I have it in your pop quiz. When you go to the website, guys, go to the website tomorrow, maximum tomorrow, take the pop quiz. That quiz is there. Now, here's the fun part about today. Here's the fun part about today. How did the scientists know that we have isotopes and they have different masses? Like, how did they know? That's my third topic. I don't know why the name is not here. I'm going to paste the name. Okay, that's my third topic. It's called mass spectrometer. But before I talk about this topic, I want to tell you about a race story. A race story. Yes, I'm going to tell you a story today at the end of this lesson. I want you to imagine that there's this race playground or race place, but it's kind of bent. Okay, so it doesn't go in a straight line, it gets bent. Okay, and then here is the finish line. All right, here's the finish line. This is the finish line. Okay, and the participants, you know, are starting in this place, and some participants are heavy in mass and some participants are light in mass, just like isotopes. There's argon 20 and argon 22. So here's argon 20. Here's my light participant, just like me, not very heavy. I think I'm 70 kilograms, pretty good. And there's this heavier argon, the argon 22, a little bit of a heavy guy. That's me when I was pregnant. Okay. You guys remember when I told you when I was pregnant and I was like really heavy and I couldn't move and I couldn't get up from bed and I'm like, oh, like I was a big ball. Oh, yeah. Yes. Look at you guys. You remember. That's amazing. All right. And then the participants are required to run in this race. So what's going to happen? The first thing I'm going to do is I'm going to be cheering these participants. So there's going to be an audience here. All right, and they're happy and smiling and clapping and they're cheering and they're like, faster, faster, faster. We want you to run faster. Okay, they're like cheering the audience, cheering the participants. There's this audience and they're cheering the participants. Okay, and so the participants in this area are going to run way faster, faster, faster. All right, okay. And so they're going to really run fast in this area, in this place. Why? Because we have this audience. All right. I'm going to tell you what this audience is. And then in this area, we want them to bend. How can I make the participants bend? I'm going to put something here. For example, I'm going to put very strong wind. Okay. To make the participants turn. And then once the participant hit the finish line, I'm going to detect the participants. I'm going to see them. All right. And so when they're exposed to the wind, they're going to turn. Question. Who's going to turn more? The lighter or the heavier? Who's going to turn more? Excellent. Alma, excellent dua. I'm going to repeat my question. Thank you. Karma, Aratrika, Samia, Habiba, Osama, Ahmed. Woo. You guys are so smart. Who's going to turn more? The lighter participant, the 70 kilogram guy, or the 100 kilogram guy? Argon 20 or argon 22? The lighter. Yes, the lighter, exactly. So this lighter participant moves and turns, but then when they turn, they heavily deflect. They turn a lot and they get detected right here. The heavier guy is still moving and he's doing his best, but he doesn't turn very much. And so he gets detected right here. And that's exactly how we were able to detect isotopes and know that we have, for example, 2 isotopes or 3 isotopes. That's what we did. We got a device. So this is the device, okay? And this device is kind of turned, is bent somehow. And we, okay, let me, just 1 second, guys. 1 second. Okay, I don't want you to see this right now. Okay. All right, so we make the sample go from this place. All right. And the sample runs in a straight line, but then I cause it to deflect. I cause it to turn. The very light isotopes will turn a lot. The very heavy isotopes will not turn very much. And so here at the detection, you'll be able to see the very light isotopes in one place and the very heavy isotopes in another place. And so you will be able to detect and separate the heavy isotopes from the lighter isotopes. Easy so far? All right. Now, what do? We do just like the race. We introduce the sample in one place. We cheer them to move faster. And then we apply something like wind to make them deflect, to make them turn. So how does that happen? Now, my first question is, do you guys want to introduce a sample that's a solid or a liquid or a gas or anything, or it doesn't matter? Ah, Rawa, thank you. Aratrika. Okay, gas only, please. Why? Because you want the sample to run a race, right? The solid is solid, and the liquid also doesn't move that much. It's got to be gas, okay? And so the sample has to be gas. And so if it's a solid, well, go ahead and melt it and vaporize it. If it's a liquid, also go ahead and vaporize it. And so in this place, it's got to be a vaporized sample. Why? Because we want it to move easily, all right? And the typo is fine. The other thing is, if you want the sample to move and you want to control the sample, you want it to run faster in one area, you want to deflect it in one area, you want to catch it, you want to detect it in another area, it's best to make your sample charged. Make it have a charge. And so we're going to turn this sample into a positively charged particle. For example, if it's argon, make it lose an electron and make it argon plus. Why? Because I want it to be charged. Why do I want it to be charged? Because a charged particle is easy to control. It's easy to make it run faster. It's easy to make it deflect. It's easy to detect it and record it. Okay? Now, how do we force argon to lose electrons? Because no argon wants to lose electrons, right? Argons are stable and happy, and they do not want to lose electrons. What if it's a chlorine? Chlorine doesn't want to lose electrons, right? Like, because we're testing isotopes, we want to see if we have isotopes of chlorine. We want to see if we have isotopes of argon, right? So how do we force it to lose electrons? We shoot a gun, kind of a gun. It's called an electron gun. So this is an electron gun. Electron gun. And what this electron gun is, it shoots a very quick beam of electrons at a very high speed. And this beam of electrons makes the atom loses an electron. It kicks out an electron by force. All right? And so it makes it positively charged. So far, so easy. And so in this part, we call it ionization. Ionization means I made the atom now an ion by force. I forced it to lose one electron so that it is now positively charged. Easy so far? Okay. Now I want to cheer up these ions. I want them to move fast, because if they're not fast, they're just going to stay here, right? I mean, I don't want them to stay here. I want them to run. How do you force people to run? You cheer them up. How do you cheer them up? You expose them to an anode right here. There's an anode right here. This is an anode. Anode is positive, right? And so your ions are positive and the anode is positive, and so they repel. And so they quickly move in this place. And so it's called acceleration. Okay? Omar, yeah. And then we want them to turn. Why? Because when they turn, the heavy ones will not turn much and the light ones will turn a lot. Right? The vaporized sample is not yet charged. And then I'm going to make it charged by the electron gun. And then I will accelerate it by moving it through an anode. And now I'm going to make it turn. I'm going to make it deflect. It's called deflection. What did I do? I don't know what I did. Okay, anyhow. It's called deflection. How do I make it deflect, or how do I make it turn? In physics, you guys learned that if you apply an electromagnet, the electrons move. That's actually how motors work. Did you guys take AS physics? Or even O-level physics will teach it, I think. Yeah, motors, how do motors work? There's electricity going on, there's a magnet going on, and then there was this rule, right, that the electricity will move in a certain direction if the magnet is moving in a certain direction. I do not remember. The Fleming's left-hand rule, thank you very much. Yeah, I remember something. Okay, and so you apply an electromagnet here. This electromagnet will cause, yeah, and then in the exam, I'll be like this, and then the person who's like, what are you doing? Are you cheating? Yeah. And then those cations, those negative, positively charged particles will deflect, will turn. And the heavy ones will not turn much. The lighter ones will turn a lot. And that's how I detect it right here. By making them turn, each one will turn differently. So far, so good. Is it easy? Now, this electron gun is supposed to shoot out and kick out only one electron. Sometimes it's too aggressive and it picks and it removes 2 electrons. That's not what we want. We just want it to be +1. That's enough for us. But sometimes, rarely, it will lose 2 electrons. It will lose 2 electrons. I don't know why it will lose 2 electrons, and it will be argon +2. Now, what was removed here is that this should be gas, and any solid or liquid should be vaporized into gas because we want it to be to move easily through the device. Okay. All right. I have a question for you. Which charge deflects more? Karma's asking, will they ask us to label? No. This is just this is just to let you know how it works, but you do not have to know how it works or the details or anything. Okay. Ma'am, can I tell you something I did for 4 days? I'm still taking. Oh, thank you. All right. So I have a question for you. Which charge will deflect more? +2 or +1? Which charge will deflect more, will turn more? The +2, exactly. The bigger the charge, the more deflection it will have. Okay, my next question. Which mass will deflect more? The smaller mass isotope or the bigger mass isotope? Which one will deflect more? The smaller. Thank you. The smaller will deflect more than the heavier. And so the smaller mass will have a more deflection. Okay. All right. So what is wrong with okay, anyhow. Guys, guess what? We're done. We have questions. I prepared some questions for you. So let's see. We're going to solve some questions here. So the first question says, which species, and you will not believe how easy. You didn't sleep for 4 days. What? All right. Which species contains the same number of neutrons as this and the same number of electrons as this? What is your first step? What is a species? Anything. Atom, ion, isotope, it does not matter. Species is basically anything. Just like the word substance, right? Species. What is a species? Yeah. What is your first step? The first step is find the number of neutrons of this. What is the number of neutrons of carbon 14? 14 minus 6, and so it's going to be 8. All right. What about number of electrons of sodium? What is the number of electrons of sodium plus? Now notice this plus. Notice this plus. How many electrons are here? Originally 11, Habiba. But the plus means that it lost an electron, which means how many electrons do I have now? Excellent. 11. I have, 10 electrons now. It used to be 11, but now it's 10 electrons, okay? And so it's asking which of these 4 has 8 neutrons and 10 electrons. What are you going to do? Simply find the number of neutrons and electrons for each of these 4 species. Neutrons, electrons, neutrons, electrons, neutrons, electrons. Quick! First one, how many neutrons? In fluorine, 17 minus 9. What's 17 minus 9? What is 17 minus 9? 8. Electrons? It is an atom. It is not an ion. And so 9. Thank you. What about nitride? Nitride. How many neutrons? 16 minus 7, which is... 16 minus 7 is what? 9. What about electrons? Originally 7, but minus 3 means what? What is the meaning of minus 3? What is the meaning of this minus 3? It means it gained 3 electrons, right? And so 7 and 3, and so there's 10 electrons. Easy, right? Okay, good. Love the participation. Neon, how many neutrons? 20 minus 10 is 10. Electrons, just 10. It's an atom. It did not lose or gain. Oxide, 16 minus 8 is, to find the number of neutrons, 8. Thank you. And the number of electrons are what? 8 and 2 electrons, guys. It gained 2 electrons. 2 here means it gained 2 electrons. So 8 and 2. And so the number of electrons here are 10. What am I looking for? I'm looking for 8 and 10. Which one is 8 and 10? Not this one. This is not 8 and 10. This is not 8 and 10. This is 8 and 10. And so this is the right answer. Guys, this is a question from past papers. What do you guys think? This appeared in March 2024. So easy, right? Okay. Another question. Just hold on for 1 second. Because it's not showing up here for me. Okay. Here's the second question I have for you. Okay. Which species contains a different number of electrons from all others? From all other 3. So your job, come on. Your job is to calculate the number of electrons in each and see which 3 are same. Oops. Yeah, I don't think my iPad likes me today. Here. And ooh, here they are. Okay. What? Where's all my work? Oh. Anyhow. Okay. All right. So it says here, which species contains a different number of electrons from all others? Different number of electrons from all others. So your job here is to find the number of electrons of each. So find the number of electrons here, find the number of electrons here, find the number of electrons here, and so on. So what is the number of electrons in ClO4 minus 1? What is the number of electrons in chlorine, guys? Just chlorine from the periodic table. Number of total of electrons in chlorine. Day, I did not say the valency number. Total number of electrons in chlorine. Guys, 17. What is wrong with you guys? Yeah, 17. What about oxygen? Oxygen. Each oxygen has 8 electrons, but there's 4 oxygens, so times 4. And this whole compound has a -1, so there's 1 electron here. Can you add these up? How many electrons total? Yeah. How many total? Okay, thank you, Uday. Anyone else? Rawa, what do you mean? Rawa, do you want me to repeat, Rawa? Okay, let's repeat. The question says, which one has different number of total electrons, Rawa? Total electrons. How many total electrons are in chlorine atom? Rawa. Chlorine atom has how many total electrons? The atom itself. 17. Good. What about oxygen? What about oxygen? Periodic table. 8. But there's 4 oxygens in the formula. It says ClO4. So 8 times 4 because there's 4 oxygens. Okay? So 32. And then there's a negative on the whole thing. So there's an extra electron for the whole thing. So 1 more. So what's the total number of electrons for the whole thing? Excellent. 50. All right? Let's do 1 more. We're gonna have to do all 4. Okay? Hydrogen, how many electrons are in each hydrogen? Why 17, not 7? Oh, Aratika, 7 is the outer electrons, but there's total 17. The question did not say outer. You've got to read the question. It said different number of electrons. It did not say different number of outer electrons. Okay, Aratika? Yep. So, Karma, do we put bracket for sulfate? We don't. Just -2, right? Okay. Let's do sulfuric acid, H2SO4. The hydrogen, each hydrogen has 1 electron. So total 2. What about sulfur? Sulfur has how many electrons total? You guys have to go to the periodic table, right? What does sulfur say? Let's go to sulfur. Where's sulfur? Okay, here. 16? Okay, someone said 16. All right, I'm going to trust you. It is 16. What about oxygen? There's 8 times 4 because there's 4 atoms of oxygen. Are you guys all following? So what's the total? Thank you, Samia. Thank you, Uday. Total is 50. Awesome. Very smart. All right. Sulfate. Sulfate. Sulfur is 16. All right. Oxygen is 8 times 4. And there's 2 electrons extra because the compound says SO4 -2. So there's 2 more. And so when you add all those up, it's going to be what? 16, 8 times 4, 32 plus 16 plus 2. That's also 50. All right. What about tellurium? What about tellurium? Oh, this one needs a periodic table. I don't have that memorized. Let's go to the periodic table and find tellurium. Here's tellurium. How many electrons does tellurium have? 52. 52, right? And not just 52 original, but it says tellurium -2. So 52 and it gained 2 electrons, right? It gained 2 electrons, so 52 and 2 more, and so 54. So what's the answer to the question? The question says which species has a different number of electrons from everybody else? And so the answer is D. Thank you very much. All right, next question. Which statement about iodine is correct? 131 and 53. Now, what does 53 mean? 53 means the protons are 53, and 131 is the mass number. From the mass number, we can calculate what? Neutrons, exactly. What are the number of neutrons? What is the number of neutrons? Okay, someone said, okay, Maysam, Samia, Dua, and Habiba said 78. So I trust your calculations are right. Wonderful. A negative ion, now if it's a negative ion, negative means what? Negative means it gained an electron, right? If it gained an electron, then how many electrons should be there? How many electrons should be there? 50, instead of 53, it's going to be 54. That's right, 54. So it says here, a negative ion has 53 neutrons. Woo! We got 78 neutrons. They said 53 neutrons. Looks like this part is totally wrong. This is really bad. We just got it to be 78. So this is wrong, but this part is right. 78 neutrons is right. So we're going to eliminate A and B, right? We can just quickly eliminate A and B, okay? Now, what about the number of electrons? If it's a negative ion, then the number of electrons is going to be what? Instead of 53, it gained an electron, so it's going to be what? It's going to be 50? Aha. Excellent, Maysam. Excellent, Habiba. If it was originally 53 and it gains an electron, it's going to be what? How many electrons total? Only 2 students answered this. Come on. Yes, Rawat, that's right. Yeah, 54, and this is the answer. Okay? All right, next question. Which particle has 8 protons, 9 neutrons, and 10 electrons? So our job is to find the number of, now all of them are oxygen. So the number of protons for all of them is going to be 8. So I do not really need to check the 8 proton thing, right? It's all of them are 8 protons. I don't have to worry about this. I do have to calculate the number of neutrons of each and the number of electrons of each. Okay, can you guys quickly calculate the number of neutrons for each? What is the neutrons for this one? First one, 16 minus 8, so 8. What about this one? Also 16 minus 8, so 8. Thank you, Ratrika, that was quick. This one is 17 minus 8, so 9. And this one is 17 minus 8, so 9. Thank you, Samia, Habiba, Uday, Maysam, Karma. Wonderful. Look at you guys. Okay. What about electrons? Originally, 8 electrons, but this is not neutral. This has a -1 charge. This one has a -1 charge, which means it gained 1 electron. So now it's 9. What about this one? It gained 2 electrons, and so it's going to be 10. This one gained only 1 electron, so it's 9. This one gained 2 electrons, and so it's going to be 10 electrons. Which one matches? We want 9 neutrons, so this is matching. We want 10 electrons, so this is matching. And the answer is D. Easy? You guys feel like you could, I mean, you could have answered this last year. What's the difference then in the AS level? Do you guys know what's the difference in the AS level? Yes, there's new information, but there's another important difference. The questions are slightly harder. And one more thing. You have to solve them way quicker. Way quicker. You should write this in a second. Okay? Yeah. And there's more working out. Okay? Dua, this one? So Dua, do you understand why I eliminated A and B? It said 53 neutrons, but we just found out that we have 78 neutrons. This one, Dua? This one? Okay, someone wants me to repeat this one, so everybody focus. It's asking for the total number of electrons. Where do you get the total number of electrons? From the periodic table. Sodium has 11, magnesium has 12, aluminium has 13, from the periodic table. So chlorine has 17. Oxygen has 8. However, the compound says ClO4, which means there's 4 oxygen atoms in this compound. And so there's 8 electrons in the first atom, there's 8 in the second, 8 in the third, and 8 in the fourth. So there's 8, 8, 8, 8 electrons. There's total 32 electrons. So far, so good? Good. One more thing. When they say negative here outside, it means there's an extra electron. You got it? And that's why I added one more electron here. Sulfate has 2 extra electrons. Okay, guys, let's do an exercise. How many electrons are in nitrate, NO3 minus 1? How many electrons are in nitrate? The nitrogen atom has how many electrons? And the oxygen has how many electrons? The nitrogen has 7. The oxygen has 8, but 8 times 3, so 24. And there's this extra electron, so we have one more. And so what's the total? 24 plus 7 is 31, 32, I think. Yeah, so total 32. Do you guys get it? Everyone gets it. Do you get it? All right. Okay. Sodium azide. Okay, it looks like there's this ion, there's weird ion here that is called azide. So this N3 minus 1. It consists of positive sodium ions and negative azide ions. What are the number of electrons in the sodium ion and the azide ion? So sodium azide is Na plus 1 and N3 minus 1. How did I know? Because you guys remember when the charges exchange? You guys remember this concept? Here's the sodium plus 1 and here's the minus 1. The one comes here, the one comes here. You guys remember this? And they cancel out each other. And so this is the formula of the sodium, which is easy. This is the formula of the azide, which was not easy, right? But I could figure it out from the formula. And the question says, how many electrons are in sodium and how many electrons are in N3 minus 1? How many electrons in sodium? Originally 10. But the plus 1 means that it lost 1 electron. And so it's not 11 anymore. It lost 1 karma, so it's what now? Aha, thank you, karma. It's 10. Guess what? You just have to do this very fast in your exam, okay? Originally 11. Sodium in the periodic table is atomic number what, Oday? Periodic table. Did I say originally 10? Sorry. Yeah, originally 11, and it lost 1 electron, okay? All right, what about nitrogen? Each nitrogen, Alma, there's 40 questions per paper, okay? And you will have 1 hour and 20. Did you guys watch my orientation for the AS Cambridge? You did not watch my orientation, Alma. Oh, Alma did not watch my orientation. It's 8 minutes or 7 minutes, something like that. You have to watch it because I did not repeat this information here. Yeah, you will have more time for MCQ. Yep. Okay, so each nitrogen is 7, but there's 3 nitrogens, and so 21. But then there's this extra electron. It gained 1 electron. It gained 1. So instead of 21, I now have 22. So the answer is 10 and 22. Finally, we have a B instead of a D. Okay, easy? All right, another question. HCN has been detected. The molecules below are detected. So which molecule contains the same number of total valence? Okay, Aratrika, remember Aratrika when she said, why is chlorine not 7? And I said, because it was total. Now this one is asking about the outer shell. This one is asking about the outer shell. How many outer shell electrons are in HCN? Hydrogen has 1 outermost. Carbon has, I'm not going to say. Thank you. 4, Samia and Maisam, thank you. Nitrogen has how many outermost? Thank you, Samia. 5. And Habiba. No, actually it's 5. It's in group 5. And so total, HCN has a total of how many outermost, not total. Not total. Read the question. Read the question. Okay, how many total? 5 and 4, 9, 10. There's 10 total electrons, okay? Basically, it's asking which molecules has 10 outermost electrons. Calculate for each one. Hydrogen, 1. Nitrogen, 5. Oxygen, 6. How many total electrons here? 6 and 5, 11 plus 1, 12. Not the answer. Next, nitrogen, 5. Hydrogen, 1 times 3, so 3. And so 8. Not the answer. I'm looking for 10. Are you guys getting it? This is basically the question. This is basically an AS question. The only difference is there's more work and speed. Okay? The orientation is in the group, or after the session you can ask me or ask Miss Saba. All right, next one. Nitrogen, 5. Oxygen, 8. Not 8. Eek. Total is 8, but it's 6. Outer is 6. See, I confused total and outer. Same confusion like Aratric a few minutes ago. Total and outer. Read the question. And so 11, which is not the answer. Last one, phosphorus, 5. Nitrogen, also 5. And so 10. This is the answer. You guys get it? Nice. Easy, right? Okay. Which atom contains 4 times as many neutrons as in lithium? Question, how many neutrons are in lithium? How many neutrons are in lithium? 4. It says here 4 times 4. What is 4 times 4? What is 4 times 4? 16. So I'm looking for an atom that has 16 neutrons. That's it. I'm looking for something with 16 neutrons. How many neutrons are in calcium? 40 minus 20. So 20. Not the answer. How many neutrons are in magnesium? 12. Not the answer. How many neutrons are in phosphorus? 31 minus 15 is what? 16? Yep, that's the answer. That's the answer. That's the answer. How many neutrons are in silicon? 26 minus 14 is what? 26 minus 14. 12? Not the answer. Easy? So easy. Okay. Ooh, we're done! Yay! How was class? How was it? How was AS? What do you guys think? AS is fun. It is amazing. Yeah. Please go watch the orientation video, which is only 8 minutes. Go to my channel. You guys know where my channel is. Just go to my YouTube channel. You will find that orientation minutes. Only 7 or 8 minutes. Please watch it. Okay? I know karma. So AS level, some questions are easy, but you've got to be fast. That speed is very, very important in the AS. And so I cannot emphasize enough practice. You've got to solve many times, and you've got to repeat your solving. You cannot solve classified questions once. Once is not enough. You will get an E. You will fail the subject if you solve once. Classified should be solved minimum 4 times. I'm serious. 4 times. Why? Because speed is important. And if I give you a worksheet, you better do it. If you don't do it, I'm sorry. You're not in my class anymore. Okay? I'm serious. At this course, I'm very serious about it. All right, let's go do Kahoot. Why is Kahoot not in my... because I restarted my iPad. Okay. This is gonna take a second, sorry. Well, we have a couple of seconds to restart the Kahoot. Any questions? Does anyone wants to open the mic? Tell me something. Come on. I don't want to do this. I miss you, doctor. Oh my God, I miss you too. All right, Dua has a question. Go ahead.
Hello, ma'am.
Oh my God, Dua, how are you?
I'm fine, ma'am.
Guys,
Oh my
Dua was one of my 2024 students. She did amazing. She worked hard. She solved all my homework. She was diligent. I'm so happy to have her in class. So Dua, are you excited?
Oh, ma'am, I'm super
Yeah,
excited.
me too.
I prayed all night for you to take
Oh,
AS, and now that's what that finally it came true. I don't know how
oh,
to.
I cannot believe it. And your sister is joining the O level, right?
Yes.
Yes, awesome,
Yeah.
awesome. So yeah, it's so good to have like multiple siblings in the family.
Yes.
All right. So,
Actually, I also have a cousin. His name is Abdul Rahman Faraz, and he's also in your course.
oh, that's amazing. That is so good. All right. So you guys ready? Go
Yes.
to kahoot.it.
And ma'am,
Go.
and ma'am, my sister loves you already.
Oh, she is so sweet.
Yeah, and ma'am,
So
I have
yeah.
yeah, so sorry for cutting you off, but I didn't understand the last question that you had explained.
Okay, I cannot go out from this screen. Can you remind me? Last question. It said 4 times the neutrons as lithium, right?
Yes,
How
it's
many
the
how many neutrons does lithium have?
it has four neutrons.
4 neutrons. And the question says, which atom contains 4 times the neutrons of lithium? What is four
Uh,
times the neutrons of lithium?
16.
Exactly. So 4 times 4 is 16. Basically, you find the neutrons of each um, of the options, and then you find which one is 16 neutrons.
Okay, okay.
So calcium was 40 minus 20, which is 10. So not the answer. Magnesium was 12, so not the answer. And then phosphorus was the answer because 31 minus 15 is 16.
You're right. Yeah,
Someone joined with my name.
yeah. With practice, I can get it. All right, thank you, ma'am.
Yeah, you have. That's why I'm saying classify questions, solve it minimum 4 times. I'm serious, dead serious, 4 times. Okay, no less than 4 times. AS level, another level. All right, guys. You have 10 seconds. Okay, I'll be back in 10 seconds. Please, everyone, join. Go to kahoot.it. Click this or put this pin number. All right. All right. I think everyone joined. Let's get started. Oh, Qusay, tell him hi. Okay, let's get started. All right, first question. I think I have like 16 questions. First question. True or false? Protons determine the element identity. Awesome. Of course. Osama is in the top of the chart. That's amazing. What is mass number? What is mass number? Protons only, protons and neutrons, protons and electrons, neutrons only. Yep, protons and neutrons. Excellent job. Everybody got it right. That's amazing. I'm so proud of you guys. In neutral atom, protons are equal to electrons, protons are equal to neutrons, neutrons are equal to electrons, neutrons are greater than protons. In a neutral atom, what is correct? That's correct. Oh my God, Karma, sorry. Well, we're having fun. She said her screen froze. What is the columns in the periodic table? Columns in the periodic table. Periods, blocks, rows, groups. Columns in the periodic table. Oh, so we have some amazing genius 15 students. Yes, it is groups, guys. It's groups. Number of shells corresponds to group number, atomic number, period number, mass number. Some students answered in like literally 5 seconds. Wow. Yep, period number. Wonderful job. Thank you very much. Hydrogen in group 1. Hydrogen is in group 1. True or false? Hydrogen is in group 1. True or false? Thank you, guys. 14 students answered in 5 seconds, literally. It's false. Hydrogen is not in group 1. We spent 5. Who are the 5 people who said true? Hydrogen is not in group 1. We put it in the middle because it doesn't match everybody else in group 1. Yeah. Why is helium in group 8? Lightest gas, highly reactive, full first shell, no neutrons. Why is helium in group 8? Now the questions are going to get harder. We're going to talk about spectrometer here in a second. Full outermost electrons. Excellent. Full shell. That's right. All right. What makes noble gases unreactive? Yep, because the outer shell is full. All 15 students got it right. So proud. I want all 15 to get it right. Isotopes have the same number of electrons only, neutrons, mass number, or protons. Isotopes have the same number of protons. 15 got it right. Look at you guys. Whoa. Which hydrogen isotope has 1 proton? This is tricky. 1 proton and 1 neutron. This is tricky, guys. This is hard. 1 proton and 1 neutron, which means it's a mass of 1 proton and 1 neutron, a mass of 2. 1, 2, 3. Deuterium. Yes. Excellent. Okay. Yeah, this was hard, so I forgive you. All right. Next question. Double points. Pay attention. In mass spectrometer, lighter ions will not deflect at all, deflect more, deflect less, move slower. Lighter. Of course, deflect more. Thank you. All right, question 12. What increases ion deflection? What factor makes it deflect more? Greater mass makes it deflect more. Lower charge, greater charge, no charge. Deflect more. Yeah, the +2 will deflect more than the +1. So the greater charge will deflect more. Okay, this was also hard because it's new information. All right. Main purpose of a mass spectrometer. Produce cathode rays, determine atomic masses, measure electrons, count protons. What do you guys think we did with this mass spectrometer today? We wanted to see how heavy something is. So determine the atomic masses, right? Okay, so blue is the correct answer. Thank you. All right, question 14. In detection stage of a mass spectrometer, ions in the detection phase, which is the last thing, the finish line, ion accelerated, ions separated by neutrons, ion strike a detector, ion deflected by a field. Cathode rays. Cathode rays, you mean electron rays. Ion strike the detector. That was hard. Okay. Do you guys want Kahoot every single lesson? Double points, guys. Double points. Pay attention. If isotopes have the same charge, but different masses. The heavier one deflects less. The heavier one deflects more. They both deflect equally. They cannot be separated. The heavier one deflects less. Thank you. You guys did a good job here. Okay. All right. Number 3 is Mason. Whoa, great job. Number 2 is Olan. Great job. Number 1 is Rawa. Oh my God, look at you. And she was texting on the chat. Like, I don't know how possibly are you? Oops. I wanted to take a screenshot, but it closed the iPad. It's fine. All right. That's wonderful. Guys, you are amazing. Thank you so much. Do you have any other questions? We are done, and we are done in exactly 2 hours. Look at this. It's exactly 11:00. I cannot believe it. Any other questions today? Please join the group. Please go to clickcourses.org. Make sure you sign up before Friday because our next lesson is Friday. Oh, Alma, thank you. Friday exactly at 6 p.m. Cairo time. We will join. You guys know my time. I start right away. I start sharp. Antarctica tomorrow is for Edexcel. Tomorrow's session is for Edexcel. Okay, it's exactly the same lesson. I'm gonna repeat the whole thing. Like, yeah, I did not change any slide. Maybe the past paper questions I'm gonna change it, but everything else is the same. Okay, so Friday is the next session. Friday is a very fun topic, very new, something you did not learn before, something about the electronic configuration, a new surprise in the syllabus. All right. Yeah, those orbitals and stuff. That's going to be Friday. All right. Thank you so much. Oh, those hearts, Karma. Thank you so much. Love you all. Take care. If you have any questions, you have me, you have Miss Saba, you have Miss Dina. Thank you. Togai, babe. Thank you very much. You have our phone numbers, right? Right? You guys have everything, right? Okay. Thank you so much, all. Miss Saba just listed my phone number, Dina's phone number, her phone number. If you need anything, please let us know. And thank you, everyone. Bye. You have a great day. Enjoy. Thanks for participating. Good job. Bye.